Hello guys, welcome to my Python tutorial. In this video, we are going to talk about queue data structure. A queue is a collection of entities that are maintained in a sequence and can be modified by the addition of entities at one end of the sequence and the removal of entities from the other end of the sequence. By convention, the end of the sequence at which elements are added is called the back, tail, or the rear of the queue, and the end at which elements are removed is called the head or front of the queue. Analogously to the words used when people line up to wait for goods or services, the name is derived as queue. The operation of adding an element to the rear of the queue is known as enqueue, and the operation of removing an element from the front of the queue is known as dequeue. Other operations may also be allowed, often including a peek or front operation that returns the value of the next element to be dequeued without dequeuing it. The operations of a queue make it a first in first out data structure, FIFO. In a FIFO data structure, the first element added to the queue will be the first one to be removed. This is equivalent to the requirement that once a new element is added, all the elements that were added before have to be removed before the new element can be removed. Applications of the queue are breadth first search traversal in graph. When a resource is shared among multiple consumers, example includes CPU scheduling, disk scheduling. When data is transferred asynchronously, data not necessarily received at the same rate as sent between two processes. Examples include I/O buffers, pipes, file I/O, etc. A double-ended queue, abbreviated to DQ, is an abstract data type that generalizes a queue for which elements can be added to or removed from either the front head or back tail. It is also often called a head-tail linked list. This differs from the queue data structure or FIFO list where elements can only be added to one end and removed from the other. The general data class has some possible subtypes. An input restricted DQ is the one where deletion can be made from both ends but insertion can be made at one end only. An output restricted DQ is one where insertion can be made at both ends but deletion can be made from one end only. Both the basic and most common list types in computing queues and stack can be considered specializations of DQ and can be implemented using DQ. In queue, we can perform insertion and rear end and deletion in front end by the functions insert and queue.pop take big O of n to shift elements and insert or to delete and shift elements to the front. So we have a data type called DQ in Python in which we can use up and left instead of insert and pop left instead of pop of 0, and the operations are more efficient than the list operations. So we can import DQ from collections module. Now there is a dozen of functions applicable on this DQ, which stands for double-ended queue, and we'll discuss them all now. And to begin with, we have append function, which inserts the element x to the right side of the DQ. There is append left in DQ as the name suggests. It inserts x to the left end of the DQ. We have clear, which would remove all the elements from the DQ, leaving it with length 0. Copy creates a shallow copy of Q as demonstrated. Count x counts the number of DQ elements equal to x. Extend iterable extends the right side of the DQ by appending the elements from the iterable argument. Extend left iterable extends left side of the DQ by appending elements from iterable. Note the series of left appends results in reversing the order of elements in the iterable argument. As we can see, the order in the parenthesis is ABC, but the elements is taken separately and is inserted in the beginning, which results in CBA in the front end of the DQ. Index of x, start, stop returns the position of x in the DQ at or after the start index and before the stop index. It returns the first match or raises the value error if not found. Maxlen is used to specify the maximum size of a DQ or is considered as none by default if the DQ is unbound. Insert of I, x is used to insert x into the DQ at position I. If the insertion would cause a bounded DQ to grow beyond max length if mentioned, an index error is raised. Pop removes and returns an element from the right side of the DQ. If no elements are present, it raises an index error. Pop left removes and returns an element from the left side of the DQ. If no elements are present, it raises an index error too. Remove value removes the first occurrence of the value. If not found, it raises a value error. Reverse reverses the elements of the DQ in place and then returns none. Rotate of n rotates the DQ n steps to the right if n is positive. If n is negative, it rotates to the left. When the DQ is not empty, rotating one step to the right is equivalent to d dot append left of d dot pop. And rotating one step to the right is equivalent to d dot append of d dot pop left. In addition to the above, DQs support iteration, pickling, len of D, reverse D, copy.copy D, copy.deep copy D, membership testing with in and not in operators, and subscript reference such as D of 0 to access the first element. Indexed access is big O of 1 at both the ends but slows down to big O of n in the middle. For fast random access, we can use list insert. DQs also support add, mul and imul as demonstrated in the code snippet. You can access the Jupyter notebook in my GitHub profile. I have attached the notebook link in my description box. So that's all about DQ and Python. See you guys on my next video where we'll talk about list comprehension. Also, feel free to solve the questions in the description box and post the answers or queries in the comment section. Thank you.